In this video, I'll show you how to use eksctl tool to quickly create EKS cluster in AWS. I think it's the easiest and fastest way to get up to speed with Kubernetes in AWS. First, we will create a dedicated user for eksctl and set up a local AWS profile. For the first demo, we will simply use create command and rely on eksctl defaults to create a cluster. For the second one, we will use YAML config and create a private cluster where Kubernetes nodes will have only private IPs and a NAT gateway to access the internet. The following example will demonstrate how to create EKS cluster in the existing VPC. We will quickly create VPC with two public and two private subnets in two different availability zones. Then we will configure eksctl to use them to create a cluster. In a final example, I'll show you how to create EKS cluster with OpenID Connect provider. As an example, we will create IAM policy and map it to Kubernetes service account to allow it to list S3 buckets. Also, we will deploy a cluster Autoscaler to enable EKS to automatically scale up and down nodes based on the load in the cluster. You can find all the commands and the source code on my website and GitHub repository. First of all, we need to create a user to run eksctl. If you're just getting started, you may create or use existing user with admin privileges. A better approach would be to create a user with only permissions needed to perform its functions. For example, eksctl user should only have permissions to create and manage EKS clusters. Let me show you how to create one. Go to AWS console and select IAM service. In this example, we're going to create a user with minimum IAM policies needed to run main use cases of eksctl. These are the ones used to run integration tests. We will use both managed IAM policies and we will have to create our own policies as well. Let's create IAM policies first. I always prefer using plain JSON files to create IAM policies. Let's switch to JSON and add few statements for the first IAM policy. Keep in mind that you would need to replace the account ID with yours. You can find it in the menu on the top right. The first statement will allow all related EKS actions. The second one is to be able to get parameters from the AWS System Manager. In this case, we limit resources using the IRN Amazon Resource Names. The following statement for KMS, Amazon Key Management Service. And the last one is for logs. Optionally, you can grant some tags, but it's mostly for your convenience. They are used to identify, organize, and also for search. Give it a name, EKS All Access. At this point, I encourage you to use the same names, since we will use them throughout the tutorial. Alright, let's create this policy and move on to the next one. Let's also use JSON to define the IAM policy. It's going to be a more complicated and target IAM permissions. For some use cases, as well as for the main use case to create a cluster, we need to grant access to eksctl user to create IAM roles and OpenID Connect providers. This policy will mainly focus on IAM. Give it a name, IAM limited access, and click create policy. We can attach IAM policies directly to IAM user or follow the best practices and create IAM group first. Let's call it simply EKS for now. Next, we need to attach 4 different IAM policies. 2 of them we just created and 2 managed policies by AWS. You can filter by customer managed type if you have a lot of IAM policies. Select EKS All Access and IAM Limited Access. Next, we need to attach Amazon EC2 Full Access managed by AWS policy. And the last one, AWS CloudFormation Full Access. eksctl uses CloudFormation stacks to create clusters and instance groups. Finally, click Create a Group. Now we're ready to create IAM user for eksctl. Switch to the Users section and click Add Users. Let's call it eksctl and give it only programmatic access. When you're just getting started and want to test eksctl, you may choose to grant full access by placing it in admin group. If you have decided that eksctl is the right tool for you, you want to create a dedicated IAM user with limited permissions. Let's place this user in the EKS group that we created earlier. You can skip tags. When you create a user, don't forget to download credentials. We will use them to create AWS profile locally. Let me cut the file with credentials. Before proceeding to the next step, make sure that you have AWS CLI installed on your workstation. Depending on your operating system, you can follow one of those instructions to install the tool. To run eksctl locally, you can export environment variables with your access key and a secret, or create a profile, which is more convenient in my opinion. If you just run AWS configure, it will create a default profile. It's fine, but I don't really want to use that eksctl user for anything else rather than creating and managing EKS clusters. You can add profile option that will create a named profile. First, you need to provide access ID from your IAM user, then AWS secret access key. Also, you can set default AWS region to avoid adding it as a flag to the AWS CLI commands. For output, I usually use JSON, or you can keep it none. You can test yourself by running AWS STS getCaller identity to confirm that you created profile correctly. You should see eksctl user with your account ID. Every time you want to execute any AWS or eksctl commands, you need to add profile eksctl. In this section, we will create a simple public EKS cluster using eksctl. If you don't have eksctl installed, follow one of those instructions. By public, I mean Kubernetes cluster with nodes that have public IP addresses. You don't need a NAT gateway for that setup. The simplest way is to run create command. It will create VPC as well as EKS cluster for you. It may be the easiest way, but rarely what you want. EKS will create CloudFormation stacks to create EKS cluster and instance groups. In case of an error, you can always inspect the stack itself. You can customize your cluster by providing the flags to the eksctl tool. However, the best approach would be to create a config file. In that case, it's much easier to reproduce the same infrastructure and track the changes in Git. When the creation is completed, eksctl will automatically configure kubectl context. You can immediately access Kubernetes cluster. Run kubectl get svc to get Kubernetes API service from the default namespace. You can also run kubectl get nodes to get all available Kubernetes workers. Let's go back to AWS console and check the cluster and setup. First, let's go to CloudFormation stacks. You can find one stack is to create EKS cluster and the second one is to create Kubernetes instance group. By default, eksctl now uses managed instance groups. Now let's inspect the EKS itself. If you don't provide a name during cluster creation, eksctl will generate a random name for you. The default version for now is 1.21, which will change in the future. You can also customize this. Under the compute, you will find the managed instance group created by EKS with 2 nodes by default. Those are the 2 EC2 instances used as Kubernetes workers. They are created by Autoscaling group. However, you need to deploy additional component cluster Autoscaler if you want EKS to automatically scale the number of nodes. We will do it later in this video. Right now, desired capacity is equal to minimum and maximum number of instances. Let's copy this name we needed to destroy the cluster. Destroying a cluster is as simple as changing create to destroy and provide a name for the cluster. Be careful, it won't ask you to confirm. For this example, we will create EKS cluster with only private nodes. You still will be able to expose services to the intranet using load balancer and ingress. It's just Kubernetes nodes will not be exposed to the internet, which is rarely allowed by the companies. Also, if you have webhook and you need to whitelist external IP with a client, you can use external NAT gateway IP for that. Let's create eksctl config to define the cluster properties. You can find all the possible options here. These configs are very similar to the ones Kubernetes uses to create deployments, service objects, etc. First, provide the current API version for the eksctl. The next property kind is always cluster config. Under the metadata section, we need to specify the name of the cluster, the region where we want to create it. Optionally, you can specify the version. Availability zones are important for some regions. Here, you specify AZ zones where your nodes will be located, as well as load balancer created. For example, we can pick US East 1A and 1B zones. As far as I remember, you need to avoid US East 1E zone in this region. eksctl will create 2 subnets in each zone, 2 private and 2 public subnets. Then provide the config for your instance group. You can use managed and unmanaged EKS groups. You can read about them here, but I would recommend sticking with the managed node group. Give it a name general. Then if you want private nodes with private IPs only, set private networking to true. You can specify the instance type. I always prefer to use the largest types since you need to deploy a lot of system and monitoring components on each node as a daemon set. If you use small types as I used for this demo, those components waste lots of your resources. The desired capacity will be translated to the Autoscaling group's desired size. Let's also create a second instance group. It will use much cheaper spot instances. You can save a lot of money using them, but they can be taken away by AWS at any time. They will also have only private IPs. the same instance type T2 small. The difference is here spot equal to true. Let's also set desired capacity to 1. eksctl allows you to set labels on each node in case you want to use node selector or node affinity. You can use built-in labels as well to differentiate between instance groups. Most importantly, you need to set taints on these nodes to avoid accidental scheduling. Unless your pod explicitly tolerates those taints, they're not gonna be scheduled there. To create this cluster, provide config to the eksctl as an option. It will take up to 20 minutes to create a cluster. Be patient. To verify the cluster, you can run a similar command to get all the nodes. We should have one node for each instance group. We have 2 autoscaling groups for each Kubernetes node pool. Similar command to delete the cluster. Often you already have VPC and you want to create EKS cluster in the same network. You can do it with eksctl. You just need to provide few additional variables. To be on the same page, let me quickly create AWS VPC with 2 public and 2 private subnets. First, let's create VPC. Give it a name main. I can recommend using online CIDR calculators to define the size of your VPC and subnets. For this network, let's use /16, which will give you 65,000 IP addresses. Keep default tenancy, tags, and click Create VPC. Next, we need to create Internet Gateway to provide internet access for public subnets as well as internet access for the NAT gateway. Call it IGW for Internet Gateway and click Create. Don't forget to attach it to your VPC. Next, we need subnets. Specify the main VPC, then give it a name private US East 1A. I like to name my subnets using the type, which is private, and then availability zone, which is US East 1A. Select the same availability zone. For the CIDR, use /18. It gives you around 16,000 IP addresses. Also, by using the calculator, you can find the last IP address in this range, and you can use it to start the second subnet. Similar steps for this subnet. In this case, it will be private US East 1B. It is located in the US East 1B zone. Increment the CIDR for this subnet. It will start from 64.0. We will use these private subnets to place our Kubernetes nodes. Next, create 2 public subnets. The first one is public US East 1A, placed in the corresponding availability zone, and the CIDR starts from 128.0. The last subnet that we will create is public US East 1B. At this point, they all don't have routes to the Internet Gateway or NAT Gateway. We will fix that in a minute. Before we create NAT Gateway, I'd like to allocate the public IP and give it a tag. It will be located in the same region where we have VPC in US East 1. Create a tag, enter name for the key and a NAT for the value. At this point, we can create NAT Gateway. Let's call it NAT, and it can be placed in any public subnet with the Internet Gateway as a default route. For example, we can put it in the public US East 1A subnet. If you want high available NAT Gateway setup, you would create 2 NAT gateways and place them in different availability zones. Then you would create separate routing tables for each of them. Under Elastic IP, select the one that we just allocated. Now we need to create 2 routing tables. The first one is for private subnets. When it is created, you need to click Edit Routes and add a default route. Click Add Route, and for the CIDR, use all zeros, which represents the default route. For the target, select the NAT Gateway ID. The second one is a public table. Here you need to add a default route to the Internet Gateway. We're almost ready. The final step is to associate subnets with routing tables. Let's start with a public US East 1A subnet. Update the routing table to the public one. Now, similar step for the private US East 1A. You need to associate it with the private routing table. We have 2 more to go. Private US East 1B and finally public US East 1B. Alright, it's all done. We have 2 public and 2 private subnets. We can switch back to eksctl. Now we can create eksctl config to use existing AWS VPC. Similar beginning, API version, kind, and a metadata section with name, region, and a version of the cluster. To use existing VPC, we need to add VPC section in the config. ID should match your VPC ID. Then subnets. We need to separate them into private and public ones. Under private, you need to specify the availability zone and a subnet ID. We have 2 different availability zones, 1A and 1B. Similar setup for the public subnets. First comes the availability zone where you created your subnet with the subnet ID. The last public subnet is located in the US East 1B zone. Similar managed node group. When we specify private networking equal to true, eksctl will use private subnets that we defined previously. To create a cluster, run the same command and provide a new example to config. Let's run a quick check. We can access the cluster. Let's inspect one of the nodes in the cluster. We have a single EC2 instance. You can find that it was created in the main VPC and using the private US East 1B subnet. That's pretty much all that I wanted to show you in this example, that we can use existing VPC without a problem. Let's clean up and delete the cluster. Amazon EKS supports IAM roles for service accounts that allows cluster operators to map AWS IAM roles to Kubernetes service accounts. This provides fine-grained permission management for apps that run on EKS and use other AWS services. This could be apps that use S3, any other data services, RDS, MQ, STS, DynamoDB, or Kubernetes components like AWS Load Balancer Controller or external DNS. Let's create allow list all my buckets IAM policy to allow list all the buckets in this AWS account. We will map this policy with the Kubernetes service account. The idea is to map AWS IAM service with the Kubernetes RBAC system. Select the JSON tab and paste the policy. Give it a name allow list all my buckets. Next, create eksctl config with OpenID Connect enabled. Same cluster config kind with one exception. We're not going to hardcode the cluster version. The same availability zones. The difference is here, IAM section. Enable OpenID Connect. Then specify the Kubernetes service accounts. The first one will be the full service account located in the staging namespace. Then you can specify the IAM policy that you want to attach to the role and grant access to the service account. We're going to use the one that we created to allow list all the buckets. You need to replace account ID with yours. Then you can specify the IAM role to create, or you can leave eksctl to generate one for you. All the roles have to start with eksctl, since we initially granted eksctl user to create roles using the following pattern. You can specify if you want eksctl to create a Kubernetes service account and a namespace for you. I will create them using the YAML file, so I leave role only equal to true. The second service account will be used by the cluster Autoscaler. By default, it will be deployed in the kube system namespace. eksctl gives you a list of well-known policies that you can use. This one is for Autoscaler. You can either add policies manually, as we did in the first example, or use pre-configured policies. Then give it a name, eksctl cluster Autoscaler. Also, let's create a single instance group, but in this case, define the minimum and the maximum number of nodes. Cluster Autoscaler will later adjust the desired size based on the Kubernetes load. For Autoscaler to work, you need to provide 2 tags. First, to enable Autoscaler, and the second one with a cluster name. This cluster IRSA must match your EKS cluster name. Then autoscaling configuration. Let's create the final example, number 3. First thing, always check the connection. Let's create a Kubernetes example with a service account and a pod. This service account should be located in the staging namespace. So let's create it first. The service account. This annotation must match the IRN of the role that eksctl created for you. You just need to update the account ID. Then the pod. I'm going to use AWS CLI open source image with the command to prevent exiting on start. Go back to the terminal and apply the config. Now SSH to the pod using the exec command and provide the command to start a session. Now let's try to list all the S3 buckets in the account with this command. It returns the single bucket that I have. If you misconfigured something, you would get permission denied. The last demo is to verify that EKS can autoscale the number of nodes. As I mentioned before, we need to deploy additional component for that to work. It's called Cluster Autoscaler. First is a service account with annotation to bind IAM role with Kubernetes RBAC. Then a bunch of RBAC roles and bindings, and the deployment for Autoscaler itself. You need to match the version to EKS version. There are multiple flags that you can use to configure Autoscaler. The important part is to make sure that you have a proper tag with your cluster name, otherwise Autoscaler won't work. And some volumes with certs. Let's go ahead and deploy Autoscaler. Make sure that the pod is running in the kube system namespace. It's a good idea to check the logs as well. You can use pod labels to select Autoscaler. You can keep this on. You will see the logic that Autoscaler will use to determine when to reduce or increase the number of nodes. Now let's split the screen and watch the nodes. We have a single node right now. We need to increase the load on Kubernetes to force it to use Autoscaler. Create deployment with a large number of replicas. It's going to be based on Nginx and have 5 replicas. It should be enough to force Kubernetes to scale up. Let's deploy it now. Use a watch with kubectl command to get pods. We have a few pods in pending state cause they don't have place to be scheduled. You can describe one of the pods to check if it triggered Autoscaler. You can see the message pod triggered scaled up. It's a good sign. Let's wait a little bit. In a few minutes you should see a new node joining the cluster which will allow pods to be scheduled. Now it's ready and pods will transition to running state in a few seconds. Alright, it worked. eksctl is the easiest way to create EKS cluster. Maybe it's even easier than created from AWS console. But most likely, if you have a large infrastructure, use Terraform to manage it. I have another video explaining how to use Terraform to create EKS cluster from scratch. In that video, we will create VPC and subnets as well.